Okay, now we are going to do a second part of this suspension analysis video that we're making. On the first video that we did is in here we have the suspension system that you see in there, and then we did a free body diagram for the for both of the masses in there and produced these two differential equations that you see in there. And so using these two equations, we translated directly into a block diagram in Simulink. So now, ideally, all we would have to do is to define the parameters in here, and this should run. The first thing is in here, see this was M1G. Well, this we could put M1 and then put it times G, and that is the variables that will define that. So in the MATLAB window at the prompt, we need to be defining things like in here, M1 is equal to, let's see, this 20, let's see, in pounds. I think in kilograms is what we need to do. We need to put it 100, for example, 100 and no, 200 kilograms is M1. M2 is going to be more like 20 because it's the hub and the tire, while the other one is the car. G is going to be 9.81. Okay, what other? We need the values of K1 and K2. K1 is going to be equal to 200, let's see, 200, no, 200, and then case of 2 is going to go, a case of 2 is equal to 20 like this. So it is the tire in there. What else do we need to do? K2, the value of B is that we also need the value of B is equal to 100 here, or 10. No, let's just do 100. Okay, so when we run this, if something is not defined, the computer is going to let us know. I think these are the two positions that we want to find. So I double click on both of these to give us the answers. And so we'll see what happens. But we can ask any other variable that relates to the system. And so as an output, so now we gotta run this. Okay, where is the thing? Right here. Right there. Error evaluating this game. We forgot something. See, we forgot that one. That was called K1. Okay, instead of K, but all right. Where are we here? So we could just, to make life easier, is 1, 2, 200. Or we could just change it into the symbol. Maybe that's better. This is not K, but case 1. Okay. Now let's give it a try again. I think maybe it did work. So we have this, and then we have the simulations, and then you have this one. So to make it display completely out to scale, we go over here, and then we do over here too. See? So these are the two positions that we using the scope that way. Okay, and that's how we do the simulation side of this. Now, if we want any other variable, we could make scopes for the velocity, for any force on the system, all kinds of other stuff in here. Right now, what you see are two positions in there. And so what we need to do is um, possibly change the parameters if you want to see a different kind of behavior in here. Like for example, if you change the value of k sub 1, which would be the stiffness of the spring, and here you can go and do it at the prompt k1 in this. Okay. Say like k1, if k1 is instead of 200, maybe I put equals to 500. And then you can see what the system is going to do. You could actually come here and then run this again and then see what the display is. We have that one, and then we have this one. See, you have the much more, stiffer spring in there, but you can do the same thing for any other variables in here. For testing with the damper, for example, the B value in this case it's an important consideration in here. So that B, if we do it, if we increase it, you'll see how the system would behave. B is 100. For example, if I go and put it to 300, let's see what happens. B is equal to 300. Okay, so much stiffer damping. We don't expect to see many oscillations now. So we'll see what happens. And then we come over here to this
Display?
and go run.
Oh, you don't have a display. Can you add a
You
display
see
bar?
here, you see here much less oscillations.
Yeah.
So you're in control of what goes on with the suspension system.
You think you add a
So
you think you
we're
add a
gonna
display